Good morning all. Now in this session we are going to discuss on measures of dispersion, which are the various measures that are there which defines the variability in data sets. Now we'll see the common measures that are being used as a measures of dispersion. Dispersion simply means the variability or spread in the data sets or in a group of data that we are having. Measures of variability describes the spread or dispersion of a data set. Common measures for variability are range, interquartile range, mean absolute deviation, variance, standard deviation and coefficient of variation. We'll see first how to calculate range and what is a range. First, range is simply a difference between the highest value and the lowest value in the group of a data. It is simple to compute, ignores all the data points except two extremes, and the example of range or how to calculate a range has been given over here. Here are the raw data that we are having. The first task is to identify the lowest and the highest value in the data set. Now in this group of data, we'll be having the lowest value with 35 and the highest value as 48. That is the formula for range is equals to largest value minus lowest or smallest value in the data set. That is equals to 48 minus 35, which is equals to 30. Now another measure for variability or for dispersion is interquartile range. Interquartile range can be found, obtained using the formula that is Q3 minus Q1. Range of values between the first and third quartile is simply a interquartile range. Range of the middle half, interquartile range can be termed to be a range which is in the middle half of the group of data set, less influenced by the extremes. If one can going to add extreme values or the smallest values in the data set, it is unaffected by the values that is being added into a group of data. So simple, the formula for calculating interquartile range is Q3 minus Q1. Now we'll see the deviation from the mean, how to calculate the mean deviation or deviation from mean. If you are having a raw data that is 5, 9, 16, 17 and 18, your first task is to identify or calculate the mean in order to define the mean deviation. In order to calculate the mean deviation, mu is equals to sigma x divided by capital N, as we have discussed in the previous session, 65 divided by 5, because we are having a 5 number of observations in the data set. So we'll be having the value of mu, which is equals to 30. Now deviation from mean defines the data that is divided or that is having a variability from the mean. The value of mean is here, that is 13, and all the data is having a deviation from mean as minus 4, minus 8, plus 5, plus 4 and plus 3. Now we'll see the mean absolute deviation, which is again identifies the deviation from mean, the values that lies above the mean and below the mean. Now it is an average of absolute deviations from the mean. It has been calculated using the formula that is sigma in mode x minus mu divided by capital N. Because it is absolute deviation, we are having a mode, the values which lies in a mode or the values which is having a absolute values which cannot be affected by the plus and minuses in the data sets. We are having a x that is 5, 9, 16, 17 and 18 as one of the variable. Now we have first calculated mu, that is equals to 13. So we can easily calculate the value of x minus mu, that is 5 minus 13 minus 8, 9 minus 13 minus 4, 16 minus 13 plus 3, 17 minus 13 plus 4 18 minus 30 plus 5. The value of x minus mu is always equals to 0, or you can say the mean deviation is of the data x minus mu is always going to be a 0. Now we are having an absolute value which is not affected by the plus or minuses, so we'll remove the minuses from all the data, all the observations. So we'll be having a 8, 4, 3, 4 and 5, and total of it is 24. So we are having sigma in mode x minus mu divided by capital N, that is 24 divided by 5, and we'll be having a value of mean absolute deviation, that is equals to 4.8. Now we'll discuss population variance, or the fourth measure for finding out the variability. It is an average of the squared deviations from the arithmetic mean. Now again we are having the same example. We'll calculate the same example for variance, for finding out the variance, that is x minus mu. The formula for calculating variance, that is sigma square, is equals to sigma in bracket x minus mu whole square divided by capital N. We'll find x minus mu first. The value of mu is 30, so we'll be having the value, and the square root of it is equals to 130. 8 into 8 64, 4 into 4 16, 3 into 3 9, 4 into 4 16, 5 into 5 25, and the sum of all is 130. So we'll be having the value of sigma x minus mu whole square is equals to 130 divided by capital N, which is equals to 5. So we'll be having a value of variance. Now we'll see how to calculate the standard deviation. The same formula will be followed, but it is just under root of the variance. So we'll be having the same values. We are having a sigma x minus mu whole square, which is equals to 130 divided by 5. We'll be having a variance is equals to 26. It is simply, standard deviation is simply a square root of the variance. So under root sigma square, that is 26, is equals to 5.1 is the value of our population standard deviation. Now next is population variance. Now next is sample variance and sample standard deviation. Sample variance is the same, an average of squared deviations from the arithmetic mean. Both the population and standard deviation calculation has been same, or we are following the same formula for finding sample variance and sample standard deviation. The only difference for finding the sample variance and population variance lies over here. It is capital N in the case of finding population standard deviation and population variance, and in the case of sample variance it is small n minus 1. Same again, we'll find the same data, or will perform same calculation in order to find out sample variation and sample standard deviation. That is, x has been given 1398, 1844. The data has been given. We are going to sum it all, and we'll be having a value of x bar, which is equals to, then x minus x bar will be having x minus x bar whole square can be founded using x 2398 minus whatever the value of x bar is, and we'll be having the value of x minus x bar whole square. That is the value 663,866, or 6,63,866 divided by 5 minus 1. That is, or here 4 number of observations are there, 1, 2, 3 and 4. So 4 minus 1 will be having the value 3. By dividing this, we'll be having the value of sample variance. Now next is sample standard deviation. It is nothing but the square root of sample variance, that is s is equals to under root s square. So we'll be having the value, that is 470.41 is a sample standard deviation. Now next is uses of standard deviation. What are the various uses of standard deviation are? It is one of the indicators for finding out financial risk. It shows whether the risk lies in a finance or not. Quality control, it helps us in quality control as a construction of quality control charts, as a process capability studies. It helps us in comparing the populations. It helps in household income in two cities. If one want to compare the household incomes of two cities, then standard deviation is one of the best measure to identify or in order to compare two variables. It again helps in employee absenteeism at two plants. One can find out the employee absenteeism ratio for two plants using the standard deviation. Now, here are the standard deviation as an indicator of financial risk. One can compare the value of mu and sigma, or you can say standard deviation, in order to identify the financial risk of a company. Now, here is one of the empirical rule which is showing the distance from mean, or you can say the deviation from mean of number of observation or the values that are there in the data set. So, when the data are normally distributed or approximately normal, then these are the various empirical rules which are showing the deviations from a mean. First is mu plus or minus 1 sigma, which is having a percentage of values falling within the distances 68. It means 68% of the values are falling within the distance from mean. Second is mu plus or minus 2 sigma, which is equals to 95%. What does it mean? 95% of the all values in a data set are falling within the distances from the mean. Third is mu plus or minus 3 sigma, which is equals to 99.7. It means 99.7% of the values are falling within from the mean or distances from the mean. Now, Chebyshev theorem. Chebyshev theorem is applied to all the distribution, whether the distribution is normal, whether it is a exponential distribution, whether it is a Poisson distribution. It is applied to all the distribution. The formula for which is given over here: P and in bracket mu minus k sigma less than x less than mu plus k sigma, which is greater than or equals to 1 minus 1 upon k square for k greater than 1. We'll see now. If we'll see the Chebyshev theorem, how it is going to be used. Number of standard deviations has been given, that is equals to k. In Chebyshev theorem, the formula is 1 minus 1 upon k square. K is the number of standard deviation, how many deviations are there in a data set. So we'll be having a k is equals to 2, 3 and 4. We'll be having a distance from the mean that we have learned in the previous slide, that is distance from the mean mu plus 1 sigma, mu plus and minus 2 sigma, mu plus and minus 3 sigma. So we can easily apply the Chebyshev theorem in order to identify the variability in the data sets. Minimum proportion of values falling within the distance are 1 minus 1 upon k square. Here k is equals to 2, so 1 upon 2 square, which is equals to 0.75. 1 minus 1 upon 3 square, here k is equals to 3, so we'll be having the value that is 0.89. 1 minus 1 upon 4 square, which is equals to 0.94. So we'll be having the values of Chebyshev theorem, which is showing the proportion or percentage of values which is falling within the distance from the mean. Now, the next is coefficient of variation. Coefficient of variation is the ratio which is showing the standard deviation to the mean expressed as a percentage. It is a ratio which is showing the standard deviation which is divided by the mean or mu, you can say, which is expressed in the terms of percentage, which is again showing a variability between two variables. Is again one of the measurement of relative dispersion is going to be used in order to identify the variability. Can be calculated using the formula coefficient of variations is equals to sigma divided by mu divided into 100. Sigma is the simple standard deviation, as we have discussed in the previous, as we have seen in the previous slides, divided by mu as the mean, or you can say population mean, divided into 100. Now we'll see the calculation. We'll be having a mu, we'll be having a sigma. Mu is equals to 29 has been given, sigma is equals to 4.6 has been given. So simply you can apply the formula, that the sigma divided by mu into 100, 4.6 divided by 29 into 100, you will be having a value of 15.86. Again, for second group, the value of mu and sigma has been given 84 and 10. So coefficient of variance can be calculated for sigma divided by mu into 100, 84, 10 divided by 84 into 100, will be having a 11.90% of the variability. The data that is having a minimum number of coefficient of variation is going to be the chosen if one want to choose from the two options. So it is having a 11.90% variability, it is having a 15.86% variability. So one can choose this option if for choosing any option, from choosing any two alternatives, the data with the minimum number of coefficient of variation can be chosen. Next is measures of variability for group data in the terms of variance and standard deviation. We have discussed the measures of variability or measures of dispersion in order to find out the variance and standard deviation for ungrouped data. Now we are going to discuss the measures of variability, variance and standard deviation for group data. We'll see how to calculate the variance or standard deviation when the data is grouped, when your data is a kind of group data. For population mean or for population variance, the formula is sigma square, which is equals to sigma f in bracket m minus mu whole square divided by capital N and the standard deviation, or you can say the population variance, can be founded using sigma is equals to under root square root sigma square. This is the population standard deviation, this is population variance. Now in the same manner, the sample variance and sample standard deviation can be obtained, which is equals to s square is equals to sigma f in bracket m minus x bar whole square divided by small n minus 1. Whereas the sample standard deviation can be identified, calculated using under root s square. Now we'll see the example of calculating sample standard deviation and sample variance and population variance and population standard deviation. Now class interval has been given, that is 20 under 30, 30 under 40, 40 under 50, 50 under 60, 60 under 70, 70 under 80. We will be having a frequency 6, 18, 11, 11, 3, 1 and the total of it is 50. M is the midpoint. Midpoint can be founded using 20 plus 30 divided by 2 are the class intervals. F into M, because we'll first have to find out the mu in order to calculate the standard deviation and in order to calculate the variances. So the formula for which is sigma fm divided by sigma f. So we'll first have to identify the sigma fm, can be calculated using by multiplying f into m, that is equals to 150, 18 into 35 630, 11 into 45 495, so on. Next column is m minus mu. The formula is sigma m minus mu whole square. So we'll first have to identify m minus mu. Now m is 25 and the value of mu has been given. Now the value has been obtained by m minus mu whole square, that is 324, 64, 4, 144, 484 and 1024. Now we are going to multiply it again with the f, that is f into this column, 6 into 3 24, 18 into 64, 11 into 4, 11 into 144. So we will be having this values, and the total of which is 7200. We will put this value in the formula, that is sigma f and in bracket m minus mu whole square divided by capital N, that is 7200 divided by number of observations we are having, that is frequencies 50. So we will be having the value 144 of population variance. Now population standard deviation can be found using under root sigma square, that is sigma is equals to under root sigma square. So we will be having the value of population standard deviation, which is equals to 12. Now, thank you.